Hello dear students, in this video we are going to solve this question. Which variable affects the equilibrium constant Kc atmospheric pressure? So to understand this variable, we have to understand that the molecules involved in the reaction are the gas molecules. And if we increase the pressure, then the equilibrium system counteracts that change. Means if the gas molecules are in a container and piston is above the system, so if we increase the pressure, means if we move the piston downwards, then the position of the piston will be here and these gas molecules will occupy this much volume now. So if we count the number of gas molecules per unit volume, the number of gas molecules per unit volume increases. So the system now tends to counteract this change, means it favors the reaction in which the products have less gas molecules. So it will counteract this change in pressure, and that's why the concentration of the reactants and the products remains same. And this value of the equilibrium constant Kc is the ratio of the concentration of products and the reactants. So if the concentration of the products and the reactants remain same, the Kc value will also remain same. Means atmospheric pressure will not affect the equilibrium constant value. The change in atmospheric pressure will not change the equilibrium constant value. So this is wrong option. Next is catalyst. So if we add the catalyst in this system, it will increase the rate of the forward reaction as well as the backward reaction equally. So it will not change the equilibrium constant value, as well as it will not affect the position of the equilibrium. Means it will not shift the equilibrium in any direction. So this is also the wrong option. Next is concentration of reactants. So again, in this case also, according to the Le-Chatelier's principle, if we increase or decrease the concentration of reactants, the system tends to counteract that change by favoring either the forward reaction or the backward reaction. So if we increase the concentration of reactants, then it favors the forward reaction so that the reactants consumed and the concentration of the reactants decreases. And if we decrease the concentration of reactants, then the system favors the backward reaction in which the reactants produced, means the concentration of reactants will increase, which means that the concentration of the reactants remains same. And if the concentration of the reactants remains same, the concentration of the products will also remain same. Means this whole ratio remains same, the value of the equilibrium constant will also remain same. So this variable will also will not affect the equilibrium constant value. Next is temperature. So if we increase or decrease the temperature, the equilibrium system again counteracts that temperature change. Means the temperature of the system will remain same. But for that, the system have to favor the forward reaction or the backward reaction. Means either the concentration of the products increase or decrease. Means this ratio will change, the equilibrium constant value will change. So this variable will affect the equilibrium constant value. So answer should be D option. Let's check the mark scheme. Yes, you can see here mark scheme also shows that D option is right. So this is the solution of this question. These are the concepts behind this question. If still you have any doubts, you can ask me in the comment section. And don't forget to subscribe my YouTube channel. Thank you so much for watching. All the best.